Section 6.5 is the average value of a function. So think about average. To find an average, we add things together and divide by how many items there are. So if you have 5 pieces of something and 8 pieces and 12 pieces, you add them together and divide by 3. So 25 over 3 is your answer. So average value of a function brings that concept in, but we're going to work with curves and the average value of the function. So as you can see from your textbook, here we have the average value of a function. And it reminds you that the average is the sum of the values divided by how many values there are. So they use y because we're looking at the average value of the function, and the values of the functions are y. So if you look down here, we have this notation where we add the different y values and divide by how many there are. Now when we find the average, we're going to divide the interval. Let's go back to this line. You divide this interval into whatever interval it is, into n equals subintervals, and we can call it delta x equals b minus a over n. And so like if we were looking at figure 1 and we let a be 0 and b be 24, we could divide it into the intervals, and we use this delta x equals b minus a over n. So when we find the average value of the function, let me switch colors. If we find the average value of the function, we take the sum of the y values and divide it by n, how many there are, so we can solve this for n. So n equals, we're going to multiply n to the other side, so we have n times delta x equals b minus a. So n equals b minus a over delta x. And we can plug that back into our average for n, and it comes up here. Now, we can factor out the b minus a, it's in the denominator, so we call it 1 over b minus a. And then we have times f of the sum of the f values times delta x. Now notice that notation should start looking familiar. We're going to distribute the delta x right here, and then we have this notation which turns into an integral. So the average value of the function is the limit as we add these from n to infinity, and it becomes 1 over b minus a, the antiderivative from a to b of f of x dx. And that's how you find the average value of the integral, the average value of the function. It's the 1 over b minus a, the integration from a to b of f of x dx. Now you need to know that. So every time you use it, write it down. And when you do that, then the problems will be not too difficult. So example 1 says find the average value of the function f of x equals 1 plus x squared on the interval from -1 to 2. You're going to have to write that formula down and make a note of it. We're going to use it many, many times. So make a note of it, pause the video. So now we're going to actually find the average value. So we're going to use f sub average equals 1 over b minus a. Write it every time from a to b, f of x dx. So we have 1 over, the interval is 2 to negative 1 to 2, so we have 2 minus -1. The integration from -1 to 2 of 1 plus x squared dx. So we have 1 over 2 minus -1 is 3. Now we can go ahead and integrate. This is not a hard one. So we have x plus 1/3 x to the third from -1 to 2. And we have 1/3. Now when we plug in 2, I have 2 plus 8/3 minus -1 minus 1/3. I find that if I don't use parentheses, I tend to lose negative signs. So I write it out. Some of you need to write it out too. Feel free. So now I have 1/3. I have 2 plus 8/3. Minus becomes a plus 1, and minus becomes a plus 1/3. Now I like to distribute when I have fractions because often they work out nicely. So we have 1/3 2 plus 1 is 3. 8/3 plus 1/3 is 9/3, which is also 3. And 6 divided by 3 is 2. So that tells us that the average value of that function is 2. It's not a difficult concept. It's not very hard. It just takes some practice.